the question that we have here is sub dy dx equals to, we have to solve the this equation that we have here. Sub dy dx equals to x squared plus 2 over y at x comma y equals to 1 comma 2. So we have to find the particular solution of this differential equation that we have here. So now it's under particular solution. We have to find the particular solution of this differential equation. So now the first thing that we need to do here is to write this one in standard differential form. So now to write this in standard differential form, then we'll cross multiply. So this will multiply this, and this one will multiply this one. So by the time we cross multiply, we're going to have x squared plus 2. Here we're going to have dx equals to y dy. So we need to cross multiply from here so that we can put this in standard differential form, so that we can separate the variables, then we'll integrate both sides. So now from what we have here, we can still write it as x squared plus 2. Here we have dx minus y dy equals 0. So what we have here, we can still write it as this by bringing this y dy to the other side of the equation. So now we have x squared plus 2 dx minus y dy equals to 0. So now the next thing is to integrate both sides. So we can integrate this side, integrate this particular side, and integrate the other sides too. So now we are integrating both sides. So we have this minus integral y dy equals to integral of 0. So now from what we have here, so we can integrate x squared with respect to s. So we are going to integrate 2 with respect to s. Now we are integrating this y with respect to y. Then we integrate 0 as well. So now when you integrate x squared with respect to s, that will give us s squared, that will be s cubed over 3. So add 1 to the power of the x. So since we have s squared here, so integrating s squared, that will give us s cubed over 3 plus integrating plus 2 with respect to x, that will give us 2x. Now here we have minus integrating y with respect to y, that will give us y squared over 2 equals to integrating 0. So by the time we integrate 0, that will give us constant c. So when we integrate 0, that will give us constant c. Integrating s squared with respect to it, that will be x raised power 2 plus 1 over 2 plus 1. That will give us s cubed over 3 plus this is a constant. Whenever you integrate a constant, we just put x at the back. Since we are integrating with respect to x, now here we are putting x at the back. So let's say we are integrating with respect to y. That means this will turn to 2y. So now from what we have there, we have to obtain the particular solution at point x equals to 1 and point y equals to 2. So now, so to obtain the particular solution at point x comma y equals to 1 comma 2. So that is, anywhere we see x, so we can make this particular equation star, so that wherever we see x in this particular equation, then we'll put 1. Wherever we see y, then we can put 2 to obtain the value of c, so that we can obtain the required solution, the required equation. So now from here, that means we have 1 raised power 3 over 3 plus 2 into 1 minus the value of y here, so that will be 2 raised power of 2 over 2 equals to c. So now the value of x is 1 and the value of y is 2. So from here we have 1 over 3 plus 2 minus 4 over 2 equals to c. So now 4 over 2 will give us 2. So from what we have here, we can find the LCM of everything that is here by putting this over 1. The LCM of everything that we have here is 6. 3 goes in 6, that's 2. 2 times 1, that will give us 2. 1 goes in 6, so 1 can go in 6, that's 6 times 2, that will give us 12. Minus 2 goes in 6, so that's 3 times 4, that will give us 12 as well, equals to c. So this will cancel this. So I need to have 2 over 6 equals to c. So now from this particular place, we can just say 4 over 2, that will give us negative 2. I need to have 2 here. So plus 2 minus 2 will give us, that one will cancel, so that we can have the value of c to be 1 over 3. So the value of c is 1 over 3. From here, we can actually obtain the value of c from here directly to be 1 over 3. So now 2 can go here 1, 2 can go here 3. So therefore, the value of c is equals to 1 over 3. So this implies that the required solution, that is the particular solution, is s cubed over 3 plus 2x minus y squared over 2 equals to 1 over 3. That is, we'll go directly to the equation star. So this equation star, you can call this one primitive. So this is a primitive because it involves an essential arbitrary constant. So that's the primitive. And what we have here, you can call this one a differential equation because it involves a derivative. So this involves a derivative. So we can call this one a differential equation. This is a differential equation, and this one actually contains a primitive that is called. This one that contains the constant. That one is called the primitive, and it is actually from the primitive that we obtain a particular solution. So now, if you are given a question, if you are given any particular question and you have to obtain the particular solution, that is, if the value of x and y are known, that means you have to obtain a particular solution. That's what the question is all about. You must obtain the primitive. If the primitive is not given, you must find the primitive. So now, from the primitive, you can obtain the value of the constant. So now, to obtain a particular solution, so this one contains no constants and there is no differential here, so there is no derivative over here. So this is a particular solution. Kindly like this video and follow for more. Thank you.